Okay, here's example 3 from 4.9. We're going to continue talking about antiderivatives and integration. They get a little more complicated as we go through, so we're going to do a couple good examples right now. In example number 3, it asks us to find all functions g such that g prime is 4 sine of x plus 2x to the fifth minus the square root of x all over x. And so they give us the derivative of g, and they want us to find the original g, OG, right? And so we've got to find the antiderivative, or the integral, of this function. And so I want to find the integral of 4 sine of x plus, now this second piece looks a little bit funky, right? And so we might have to rewrite this into a rule that we do know, because remember, there is no quotient rule for antiderivatives. And so I don't know about you, the first thing I noticed is that square root, so I'm going to change him to an x to the 1/2. So now I have the problem that says I want to integrate 4 sine of x dx, and if they're separated by plus or minus signs, I should be able to do this piece first and this piece second, and then just put them together. As long as it's just a plus or minus sign, I should be able to separate them. So in my second piece, I still have to rewrite it so that it's not a quotient anymore. So when I go to take this second piece, I am going to actually separate them into separate fractions and then reduce. So I'm going to take an x, reduce an x out of each of those terms. That leaves me with a new integral of 2x to the 4th minus x to the 1/2 dx. Remember, I'm reducing each one by an x. Okay? So now I can integrate them separately. For the first piece, the antiderivative of 4 sine of x is really negative 4 cosine of x. Yes, there is a plus c, but there's also going to be a plus c for my second piece, and so two numbers added or subtracted together is just going to give me another number in the back, and so I'm going to add my plus c at the very end when I do all my pieces. So in my second piece, we should be able to integrate each of these now separately using my power rule, and so I have a final antiderivative, a g of x, as negative 4 cosine x plus 2x to the 5th over 5 minus 2x to the 1/2. That's me adding 1 to the exponent and dividing by the exponent, or multiplying by the reciprocal. That's how it turned into a 2 instead of a 1/2. And then my plus c at the back. And so now this is the original function that has a derivative of what they gave me originally. Okay? All right, here's a couple more. They're a little more complicated, but these are very good examples, things that we're going to see on the homework and the exams. So I want you to take a look at both of those. I want you to see if you can rewrite both of these into rules that we do know. Pause your video, try it, and see how far you get. So on the first one, A, I took that x, the square root of x, and I changed it into x to the 1/2, and then this time I brought it up. You don't have to do it this way. You could have separated it into two different fractions and reduced it that way, but we still should end up with the same final answer. I just decided to take the x to the negative 1/2, bring it up, that's how it turned into a negative, and then distribute it through to my x plus 1. So I end up with a new problem that has a little f of x to the 1/2 plus x to the negative 1/2. Now I should use my power rule, add 1 to the exponent, and divide by that new exponent. So I get an antiderivative of 2x to the 3/2 over 3 plus 2x to the 1/2 over 1 plus c. Okay? All right, B has a little bit of trig in there. And remember, there is no such thing as quotient rule, and there also is no such thing as chain rule. So that cosine squared would really be a chain rule if we were doing derivatives. But there is no such thing as quotient rule. There is no such thing as chain rule. So somehow we have to rewrite this problem into a rule that we do know. And just like derivatives, you cannot just take the antiderivative of the top, the antiderivative of the bottom, and try to smush them together. It doesn't work that way. So how can I rewrite this problem? Well, I noticed that I actually have two cosines on the bottom. Cosine times cosine is really the same thing as cosine squared, right? And so why can't I separate them instead of putting them together? But then I also noticed then that now I can rewrite this problem as a sine over cosine times 1 over cosine. That's the same as this, which is the same as my original. I haven't changed my problem at all. I've just rewritten him legally into different pieces. So now how does that help? Well, isn't sine over cosine the same thing as tangent? And isn't 1 over cosine the same thing as secant? And so now I have a little g of secant tangent, or tangent secant, secant x tangent x. Well, isn't there an antiderivative for secant x tangent x? Isn't that secant x plus c? And so I was able to rewrite my original into a rule that I do know, and I know that the antiderivative of secant x tangent x is really just secant x plus c. Okay, so those last couple of problems are just making it so that I can rearrange, rewrite into rules that we do know so that we can apply our antiderivative rules. Keep practicing. Let me know if you need